Heptapartitioned neutrosophic soft sets. They've been presented by Said Brumi and me in July 2022, and they can be considered as a combination of heptapartitioned neutrosophic sets introduced by Rada and Stanisław Ulmeri more than 1 year ago in 2021, and soft sets defined by Molotsov in 1999. So first, we should recall the word definition of heptapartitioned neutrosophic set as it was presented by Rada and Stanisław Ulmeri. Heptapartitioned neutrosophic set may be considered as an extension of typical neutrosophic sets of Smarandache, but the idea is that now we have, as you can see, we have 7 logical values. Each of them takes is a number from the interval 0, 1, and they sum up to any number not bigger than 7, as you can see here, and of course not lesser than 0. So we have truth membership, relative truth, contradiction, unknown membership, ignorance, relative falsity as K, and absolute falsity as F. So if you need 7 logical values, then you may use heptapartitioned neutrosophic sets. And here is their soft version. As maybe you know, soft sets are in some sense parametrized families of subsets. So in our case, as you can read, if we have the power set of all heptapartitioned neutrosophic sets on our universe, on our initial universe, and if we have some set of parameters or criteria and some non-empty subset A contained in this E, in this set of parameters, then the collection JA is termed to be a heptapartitioned neutrosophic soft set, where if J is a mapping from this set of parameters or criteria into the power set of our universe. And we use the following notation, or this one, which is simpler, to describe the true value of x when x is evaluated from the perspective of criterion E, and the same for other logical values. We will see some examples, but at first let us say, what does it mean that a heptapartitioned neutrosophic soft set is contained in another HPN and SS? The idea is that the set of parameters of the first set is contained in the set of parameters of the second set, and we have the following relationships between logical values, between all these functions of truth, falsity, and so on. Of course, you may stop video at this moment and check this definition. All these definitions of inclusion and like this one of complement and of union and intersection, they are in some sense arbitrary. You may define your own definitions, but I would say that there is some logic behind these definitions. For example, in case of complement, it is natural, as you can see here, to assume that the true value of complement, of course with parameter E and object X, is just like falsity value of our original HPNSS J. Okay, so there is some logic behind those definitions. You may analyze this. The same with intersection. So in case of intersection, as you can read, we are interested, in case of truth, we are interested in minimum of the truth from J and the truth from D, minimum of relative truth, as you can see here, minimum of contradiction, but maximum of unknown, of ignorance, of relative falsity, and of absolute falsity. Of course, you may change these definitions if you need something different for your applications. As for the union, the idea is that we should add those sets of parameters, and then those definitions are rather complicated, mostly because we have 7 logical values, yes? So you may analyze those definitions, true values and other values in case of union of 2 heptapartitioned neutrosophic soft sets that are here. Here is an example. Assume that our universe consists of 3 elements. Our U is x1, x2, and x3. This is taken from our paper, and this was about hypothetical political leaders, and they've been evaluated, rated on 7 criteria, 7 parameters, E1, E2, and so on, and finally E7. And for example, we have this heptapartitioned neutrosophic soft set D with a set of parameters B, and the set of parameters is E3, E4, and E5. Here are our objects, our hypothetical political leaders, x1, x2, and x3, and here are their evaluations. For example, x1 under criterion E3 takes 0.70 for truth, 0.0 for absolute falsity, and so on. Analogously, we may take C, E2, E3, E7 as our parameter set. So we do not have to use all those 7 parameters, yes? We may choose some of them. And now we have those evaluations. Of course, they are, artificially invented by us. This is just an hypothetical example. And then we may check this calculation. We may calculate the intersection. So in case of intersection, we must check if there is any common parameter, and this is E3, because here we, as you can see here, we have E2, E3, E7, and here we have E3, E4, E5, so the intersection of parameters of criteria sets is exactly E3. And then we just use those operations which have been defined here. So for example, to find the value of truth of x1 under criterion E3, we should do something like this here to find the minimum of truth values. So x1 under E3 has 0.70 in this set and 0.65 in this set. So in case of intersection, we are interested in minimum of 0.70 and 0.65, so we get 0.65. So you should check if everything is calculated in a correct manner here, if you have some time. We may also define more complex operations, namely AND and OR. AND is defined in the following manner. We use this symbol, and now it's slightly different, because instead of a typical set of parameters, we have a Cartesian product of those sets of parameters, and membership functions are defined in the following way. If we want to evaluate some element x, and we have these 2 parameters E, F, then we should take minimum of evaluation of x by means of the set J and criterion or parameter E, and in case of D we take F. Okay, you may check in our paper how this can be interpreted, yes? And something similar is for this operation OR. So as you can see, there is a lot of writing here, so I assume that you should check our paper or just stop this video and analyze those examples and those formulas and those examples. So for example here, now our universe is very simple. It consists of 2 elements, x1 and x2, and we have 3 parameters, E1, E2, and E3. And the first set, JA, it uses only 2 parameters, E1, E2. The second one uses E2 and E3. And now we take the Cartesian product of parameters sets. So we get E1, E2, E1, E3, E2, E2, and E2, E3. And for example, X1 under the criterion, or this rather the product of criterions E1 and E2, how we may calculate this, we take, as you can read here, in case of operation AND, for example, truth may be calculated as a minimum, should be calculated as a minimum, of the true value of X under the criterion E in the set J, and true value of X under the criterion F in the set D. So we take those two sets. We are interested in E1, E2. So truth of X1 in this set under E1 is 0.10. Here we have 0.47. And we take minimum of these values to get this 0.10. And the same in other cases. We proved many algebraic properties of those heptapartitioned neutrosophic soft sets, and you may find all the theorems and proofs in our paper. We defined some special cases like empty set or relative absolute set and so on. And among all those properties are, for example, those two and those two. Check this difference. Here, here, for example, we have that, that JA is contained in DA if and only if their intersection is just GA. So these are very typical Boolean properties, but one has to check them. The same here. Yes, this is like the Morgan laws. And C, of course, it is complement. So other theorems of this kind were proved. Some of them rely on those and or operations. So there's quite a lot of calculations there. And we have shown that the particular choice of exactly 7 neutrosophic logical values has an interesting interpretation in terms of ancient Jaina logic. Jaina is an ancient logic, ancient philosophical and religious system in India. And their logic has been developed centuries ago to deal with imprecise knowledge in the matter of paraconsistency. So here you have the bibliography. Here is our newest paper, the one about those sets which I've described in this video. Just as I said, there is a lot of calculations, there is a lot of symbols, but in general the whole idea is not very complicated. And this is the original paper on heptapartitioned neutrosophic set. This is Molodtsov paper on soft set theory and its first results, and the first paper on neutrosophic soft set by Babita Kumarmaji, and before heptapartitioned sets there were also pentapartitioned neutrosophic sets with 5 logical values. Thank you very much for your attention.